we want to prove that root 2 is an irrational number. Again, we're going to use the method of contradiction. Irrational means that a number cannot be expressed as a ratio or cannot be expressed as a fraction. Therefore, we are going to make the assumption that it can. Remember, the method of contradiction means making an assumption and then showing that that assumption can't be true. So the assumption that we make here is that root 2 can be expressed as a fraction a over b, where a and b are both integers, so we need them both to be whole numbers, and also that a and b have no common factors. So we're assuming that root 2 can be expressed as a simplified fraction. In other words, not as 4 over 6, but as 2 over 3, a fully simplified fraction where there are no common factors between the numerator and the denominator. So let's work with this expression. This gives us that a is equal to b times root 2, and squaring both sides gives a squared is 2 times b squared. Since b squared is an integer, it follows that a squared is even. If a squared is even, it follows that a itself must be even. And therefore, we could write a as equal to 2 times c, where c is also a positive integer. If we now substitute this into here, this means that 2c all squared is equal to 2b squared. So 4c squared is equal to 2b squared, and this gives us 2c squared is equal to b squared. This tells us that b squared is even, and it follows from this that b is even. And here is our contradiction. We made the assumption that a and b had no common factors, but we've shown that they are both even and therefore must have a common factor of 2. Therefore the original assumption is false, and root 2 cannot be written as a fraction. If it cannot be written as a fraction, it is irrational.